Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: using GenAI to filter false positives. Utilizing generative AI to filter false positives in cybersecurity alert systems is an innovative approach that addresses one of the most persistent challenges in the field. False positives occur when benign activities are incorrectly flagged as threats, leading to unnecessary investigations and resource allocation. This often overwhelms cybersecurity teams, diverting their attention from genuine threats and reducing the overall efficiency of security operations. By integrating GenAI into alert enrichment and management processes, professionals can significantly enhance the accuracy of threat detection systems, enabling a more focused and effective response to real threats. Generative AI models have demonstrated remarkable capabilities in understanding complex patterns and making informed predictions. These models can be trained on vast datasets to distinguish between true threats and benign anomalies, effectively reducing the incidence of false positives. For instance, OpenAI's GPT models have been used in various fields to generate human-like text, but their underlying architecture can also be adapted to classify and filter alerts. By training GenAI on historical security data, organizations can develop models that recognize the nuanced differences between false positives and legitimate alerts. One practical tool that leverages GenAI for filtering false positives is security information and event management systems. Modern SIEM tools, such as Splunk and IBM QRadar, incorporate machine learning algorithms that can be enhanced with GenAI capabilities. For example, Splunk uses machine learning to analyze patterns in network traffic and identify anomalies. By integrating GenAI, these systems can be trained to better understand context, such as distinguishing between normal user behavior and potential security threats. This integration enables SIEM systems to provide more accurate alerts, thus reducing the number of false positives and improving the efficiency of cybersecurity teams. Frameworks like MITRE ATT&CK, a globally accessible knowledge base of adversary tactics and techniques, can also be enriched with GenAI to improve the accuracy of threat detection. MITRE ATT&CK provides a comprehensive framework for understanding cyber adversary behavior, which can be used to train GenAI models on identifying specific attack patterns. By aligning GenAI models with MITRE ATT&CK, security teams can develop a more precise mapping of potential threats, allowing for a more targeted response and reducing the likelihood of false positives. A step-by-step application of GenAI to filter false positives involves several key stages. Initially, the organization must gather and pre-process a substantial dataset of historical security alerts. This dataset should include labeled examples of both true positives and false positives to train the GenAI model effectively. Next, the organization should select an appropriate GenAI architecture, such as a transformer-based model, and fine-tune it using the pre-processed dataset. The fine-tuning process involves adjusting the model's parameters to optimize its ability to distinguish between genuine threats and false positives based on the training data. Once the model is trained, it can be integrated into the organization's existing cybersecurity infrastructure, such as SIEM systems or intrusion detection systems. During this integration phase, the model should be continuously monitored and updated with new data to maintain its accuracy and adapt to emerging threats. Regular performance evaluations are crucial to ensure that the model effectively reduces false positives without compromising the detection of true threats. Organizations can implement feedback loops where analysts review and validate the model's decisions, providing additional data for retraining and refinement. Case studies have demonstrated the effectiveness of GenAI in reducing false positives. A study explored the use of AI in email threat detection and found that incorporating machine learning algorithms significantly reduced the number of false positives. By applying similar techniques to network security alerts, organizations can achieve comparable improvements in accuracy and efficiency. Additionally, statistics from a report indicate that organizations using AI-based security tools report a 50% reduction in false positives compared to those relying solely on traditional methods. Despite the advantages of using GenAI to filter false positives, there are challenges that organizations must address. One significant challenge is the risk of overfitting, where the model becomes too specialized to the training data and performs poorly on new, unseen data. To mitigate this risk, organizations should employ techniques such as cross-validation and regularization during the training process. Additionally, maintaining a diverse and representative training dataset is crucial to ensure the model's robustness and generalizability. Another challenge is the potential for adversarial attacks, where malicious actors manipulate input data to deceive the AI model into making incorrect predictions. To defend against such attacks, organizations can implement adversarial training, where the model is exposed to manipulated data during training to improve its resilience. Furthermore, employing explainable AI techniques can help analysts understand the model's decision-making process, increasing trust in its predictions and facilitating human oversight. In conclusion, leveraging GenAI to filter false positives in cybersecurity alert systems presents a transformative opportunity for organizations to enhance their security posture. By integrating GenAI into existing frameworks and tools, such as SIEM systems and MITRE ATT&CK, organizations can achieve significant reductions in false positives, enabling security teams to focus on genuine threats. The practical application of GenAI involves a systematic approach to data collection, model training, and integration, with continuous monitoring and updates to maintain accuracy. Despite the challenges, the benefits of using GenAI in alert enrichment and management are substantial, offering a more efficient and effective cybersecurity defense. As organizations continue to adopt AI-driven solutions, the role of GenAI in filtering false positives will become increasingly critical in safeguarding against evolving cyber threats. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.